Section 4.5. Question 1. Which of the following functions is one-to-one? So as you know, we can show the functions this way or this way, or on the graph, so we can show the graph of the function. But here this means if our function is this one, so it means it's matching -2 with 2 and 9 with -4, 18 with 6, and 23 with -4 again. So as you see, so here if in a function, if there are two x values going to the same, assigned to the same y value, then this function is not one-to-one. So this is the idea. So basically, if f of x1 is equal to f of x2 for some x1 and x2, then we say f is not one-to-one. Here, as you see, f of 9 and f of 23 is assigned to the same value, -4, so f is not one-to-one. So this is not one-to-one. Now, when it comes to the other choice, and we have this here. Assume f of x equal to x squared plus 1. Now, we can show it this way, like we can show it's f of 1 is equal to 1 squared plus 1, which makes 2, and this is f of -1 is equal to, again, it's 2. So we show two x values are assigned to the same y value, so f is not one-to-one. And so that we can say this f is not one-to-one. And there's another way to do it. The other way is this. We have horizontal line test. So in addition to this definition here, we have also horizontal line test. The horizontal line test is telling us this. If you make the graph of this function, so if there are two here, I mean this is horizontal. So if you draw a horizontal line, if you can't find a horizontal line that passes through the function graph at 2 points, then f is not one-to-one. And if this is the case, and here if this is the case also, so for example, let's take this one. If this is the case, one horizontal line intersecting at 1 point only, so then we say f is one-to-one. Now, if you cannot use this approach here, like f of something is equal to the same thing, if you cannot use this approach, you can use the horizontal line test. So here we can use the horizontal line test for the rest of the functions. Now, for example, we already showed this is not one-to-one, but let's use also this one, the horizontal line test. For example, what's the graph of this? The graph of this one will be x squared shifted up 1 unit, so it will be something like this. So we have this thing here, that the one we can find a horizontal line intersecting the graph of f of x at 2 points, so this f is not one-to-one. So you can also verify that it is not one-to-one by the horizontal line test. And now let's come to this one here. We look at a graph of this, like 2 units. Look, this is the absolute value, and then 2 unit left, and then 1 unit down. So it will give us this function here. So look at here, this is the graph of this function. Y is equal to this. And now you can draw a horizontal line, and it has also 2 intersection points. So then this is not 1 to 1, not 1 to 1. Now, let's make the graph of this one. This is, if you remember, this is the graph of y equal to x cubed. And when you draw any horizontal line, you will see there is only 1 point, intersection point with the graph. So this is the case here, so it will be 1 to 1. So f is 1 to 1 here. So there are 3 types of checking, the 1-to-1ness with the horizontal line test. If you have the graph, and if you can find like the numbers same are assigned to the same y value, then you can say it's not 1 to 1. So as a summary, you can check the graph, check the numbers, like if they are meshed to the same thing, or you can find 2 numbers, like here it's easy, not 1 to 1. It shows you it's not 1 to 1, but here it's not easy to find such numbers, so you can make the graph here like the horizontal line test. Also, you can use this one here, also horizontal line. You can use horizontal line here, but we don't use the horizontal line here because this graph, we don't make the graph of this. Now, if f of x is this, which of the following is f inverse 2? There are 2 ways of solving this problem. The first way is this one here. Let f inverse of 2 is equal to a. Then, here, think about this. If you have a function here as f, goes to 2, and if you say this is f inverse, it goes to a, let's say, so it means this. So what does this mean? It also means f of a is equal to 2. Right? So then this means f of a is equal to 2. What is f? F is this one, cube root of, for a is equal to f of a is equal to 2. Then you solve for it. 4a is equal to 2 cubed, and this is a is equal to 2. And you can say it's equal to 2. And the other way is, second way is you can try to find the inverse of this function here. You can use your method to find the inverse, and I will use mine. Cube of both sides. Then you have 4x, then y cubed over 4 is equal to x. Then I change this one to f inverse of x. So this is the inverse of f. Now you can substitute 2, and you will get 2 cubed over 4, which is 2. This is the second way. I mean, it comes to the same thing. This and this. I mean, we do the same thing indeed. This is more practical. I mean, for more practical if you have some experience. But this is a little long. But if you think this is the safe method, you can do it. Now, which of the following is the inverse of this function? Now, we start with changing f of x to y, and then solve it for x. So it means we want to solve it for x, and we want to get x equal to what? Now, this is the first step of finding the inverse. So here, this is the first step. Step 2 is changing them. This is f inverse of x, and it will be x minus 1 squared plus 2. Okay, in high school, there's the other method. The other method is like most of the students are doing it this way, I guess, and for me, it's okay. As long as you get this one, it's okay. Like they reverse this x and y first. They write this one x equal to square root y minus 2. Okay, this is the second way. And then they find y. They find this one x minus 1 squared plus 2. And they say f inverse of x, and then this is x minus 1 squared plus 2. This is another way. I mean, you can do it also. You can do this one. But we are doing it this way for a reason. I mean, when we have a question about restricted domain, this method works better, not this one. So which of the following is the inverse function? So I will use my method again. First, write y is equal to 1 over x plus 4. And then step 1, solve for x. And okay, what we can do here is you multiply both sides with x plus 4 both sides, and you will get this one 1. You have xy plus 4y is equal to 1. Now we have the x term here, and now we send the other side, everything to the other side, and we end up with dividing by y, so we get this one x equal to 1 minus or y divided by y. And now you can change this one to f inverse of x. This is now I'm doing step 2 here. I'm changing x with f inverse of x, and it's equal to y with x divided by x. And then you can separate them, and when you separate them, you will get this one. You know, this is the answer. This is final answer. It's okay. But when you look at the choices, we don't see this one. So it's better we split them, we separate them, and then we make this simplification, and we will end up with x minus 4, which is a. Again, as I said before, you can do it the other way as you like. And here, the shortcut here in this type question, the shortcut here, the shortcut is this. If you have a over b equal to c, then you can say this is a over c is equal to b. Now here, if you do it like y is equal to 1 over x plus 4, then you can switch them, then you can say this x plus 4 is equal to 1 over y, then x will be 1 over y minus 4, and you can do the rest here like that. Or change x with f inverse and with x, y with x, then you will come to here. So this is a shortcut for solving the equation. Now, which of the following graphs represents a one-to-one function? You remember the horizontal line test, like here, if you can find a horizontal line that passing through more than 2 points, then this is not one-to-one. Now take this one, you see 2 points at least. I mean, we have 4 here. This is not one-to-one. And here we have 2 points, not one-to-one. Now look at here. At any, when you draw the horizontal lines, it always intersect at only 1 point. As you see, this is see 1 to 1. But here you have to check all points here. So, if you check all points, you will see only 1 point intersection. Consider the graph of f of x and sketch the f inverse. Okay, the first step here is when the graph is given, step 1, draw the graph, draw the line y equal to x. You can make a table. It's easy. You make 0, 0, 1, 1. So 0, 0, 1, 1, 2, 2, whatever you like. So you can find 1, 1. You can find 2, 2, and 0, 0. And then you make this line. This is given here, but in the exam you will not be given. So you have to first find this one. Then after finding this one, you will take the reflection with respect to y equal to x line. This is y equal to x line. And then you can do the reflection of each point here. This point, when you reflect it, it comes to here. It's 90 degrees. Take this one. If you want to do a precise job, you have to do the reflection well. You can do it point by point. So then it has to be something like this. So now this will be equal to f inverse of x. Okay, remember this all the time. The f and f inverse, the graphs of f and the f inverse are symmetric with respect to y equal to x line. And then, as step 2, I have to write here step 2, reflect y equal to f of x through y equal to x line. And this is what I did here. And do the same thing here to get f inverse. Here, first step, draws y equal to x line. Now you can make this x, y, 0, 0, 1, 1, and minus 1, minus 1 if you like. Minus 1, minus 1, or minus 2, minus 2, it's here, it's here. And you can find this 4, 4, 0, 0, 2, 2, whatever you like. Then you will have this line here. This is given here, but you will not be given during the exam, so you have to draw it by yourself. Now step 2, do the reflection. Do the reflection through the y equal to x line. Now it means you have to take some points here. So you take the point here and look at it. Okay, now we will do it roughly, but if you do it point by point, it will be better here. So if you have a grid, like if you have these, you can do it, precisely. You can do it here precisely, daqiq. You can make a daqiq graph, but here it's not possible. So we say this is the graph of f inverse of x. Now let's find the inverse of this one, and then we will check our answer. Now let's deal with finding the inverse first. Okay, y is equal to x plus 1 over x minus 2. Then we multiply both sides with x minus 2, and we get rid of this x plus. Okay, we get rid of the denominator. We have x minus y minus 2y. 2 minus 2y is equal to x plus 1. And then we can send this. We have x here, we have x here. We can send all the x's one side and all the others one side, so it will be 1 plus y. And then we get x times y minus 1 equal to 1 plus 2y. And when you divide both sides with y minus 1, you got this one. And this makes the first step, and we have x equal to, this was the first step here, solve for x. Now we end up with this, and then we change x to f inverse of x is equal to, we change this one with x, y with x, and here it will be x minus 1. So here, step 2, you change x with f inverse of x, and then change y with x. Anyway, we finished, and this is the inverse function. This is the inverse function. Now we will check our answer. Okay, we'll check our answer. Check. Now in checking, when you check your answer, you check two things, like you check f of f inverse of x equal to x, and you check f inverse of f of x is equal to x. Now let's check this one, the first one. Now let's check this one. Now we write f of f inverse, which is f of f inverse is 1 plus 2x divided by x minus 1. And it will be, okay, then we can put 1 plus 2x divided by, okay, now I will combine these two. This will make 3x divided by x minus 1. And this is, okay, the denominator will be like this. Then we have 2 times x minus 1 divided by x minus 1, and then you can combine them with this. Okay, raise, then you can also take this one as plus minus 2x plus 2. Okay, we have to be careful about distributing negative sign, and we will end up with 3 over x minus 1. And okay, we are done here, so it will be 3 over x minus 1. Then if you flip and multiply, you will get this one. When you flip and multiply, you get 3x over x minus 1 times x minus 1 over 3, and we'll end up with x here. So this is done, and then we need to check the other. Now I have to check this one now. I have to check f inverse of f of x. So in this case, I need to write f of x first here. What is f of x? F of x formula is this one here, x plus 1 is over divided by x minus 2. And f inverse is this one here. So instead of x, I write, this one instead of x. So it will be 1 plus 2 times x plus 2 over x minus 2 divided by x plus 2, x plus 1 over x minus 2 minus 1. And which will give us, okay, let's combine these two here, the numerator. So let's deal with the numerator. 2 times x plus 2 divided by x minus 2, and you can do x minus 2 here, multiply, you get x minus 2 over x minus 2 plus x plus 2 over x minus 2, and when you add them you will get 3x over x minus 2. Okay, we are done with the numerator. This turns out to be 3x over x minus 2. Okay, let's do this, the other one. The other one will be x plus 2 over minus x plus 1 over x minus 2. This one, which is, okay, you can do this one, x minus 2 you combine, you make this one first and then distribute minus, and you will end up with, okay, be careful about this, it will be plus here, so the x and x will cancel out, you get 3 over x minus 2. So we found the other one, it's 3 over x minus 2, and then when you check, okay, when you flip and multiply, you will end up with 3x over x minus 2 times x minus 2 over 3, and this will give us x. Okay, that's it.